Hey guys, Professor McStud is back, and I'm finding missing factors in the greatest common factor. So we're just identifying that greatest common factor, looking at these with variables, all that good stuff. So if you'll notice here on this first example, all we're doing is finding missing factors. So missing factors are going to be, we have three things are multiplied that give us something else. So basically what we're going to be doing is dividing. So what we need to do first here is we have 3rs times negative 5r squared s, so that's going to give me negative 15r to the third s squared times something. I don't know what that something is. It's going to give me the 45r to the sixth s to the fourth. So put that together. What I need to do is divide by negative 15 r to the third s squared, negative 15r to the third s squared, and so then dividing that. So divide the numbers. So you still divide the numbers, or you can just basically simplify if you need to. So then getting those two together, I end up with a negative 3. Answer come out here. So negative 3r to the third s to the second power. That is your missing factor there. Again, you can kind of sort of logic through this. I'll show you the logic through this if you want to logic through your way through this. So you still have to multiply here. So I have 30a to the sixth, b to the fifth, and we have negative 10a to the third, b to the fourth. So here you'll see, then times something. So to find that times something, remember I have to multiply negative 10 times something to get to my 30, so it's going to give me a negative 3, and then a to the third times what gets me to a to the sixth. I get a to the third because you have to multiply by something, and then b. So that is going to be my something. So remember, when you multiply, you add exponents. So to get from 3 to 6, I got to add 3. So that's where this 3 comes from. Okay, so just making sure that's kind of sort of the other way you can do this. So this next one, we're going to find the greatest common factor. So when you find the greatest common factor, you have to find the greatest number. So when we have numbers here, coefficients here, and then you're looking for the smallest power here, smallest power. So therefore, I have the biggest number between those two is going to be 14. If you 7 does work, but 14 is bigger, and then m squared. 14m squared. That's the greatest common factor. That's all we're doing. This is a building block to be able to factor by the greatest common factor. So we'll get into that a little bit later. All right, now then, this one, I need to look. There's no coefficients, so, we don't have to worry about that. So we have x to the fourth and x to the sixth. Take the smallest power, x to the fourth. Y to the sixth, y squared, smallest power there, because I don't have 6 x's to work with here, or 5. But I do have 4, so that's why we're going to do that. And I have 4 in this one as well. All right, now then, this one, we have 94 and 32. All right, so the greatest common factor of these coefficients here is going to be 2. So that's the greatest one. I know 94 doesn't seem like it. And then we have the smallest exponent of c is c to the first, which is here. And then I don't have a d and an e in both of those, so I can't use either one of those. So just 2c is there. And now then, when you have something like this, you have to find the greatest common factor of all 3 of them. So you look at all 3 numbers. Well, nothing can go into that's even, or nothing the same will go into all 3 of those. So there is no greatest common factor as far as the coefficient goes except for 1. And then we have x to the third, x to the first, x to the second. So x to the first stays there because it's the smallest power. Then we have y to the fifth, y to the fourth, y to the eighth. It's going to be y to the fourth. That's the smallest power there. So it's going to be x, y to the fourth. That's what I have for you for missing factors. Remember, you're kind of dividing, or you can logic through it using kind of that exponential rules as far as multiplying and adding exponents. And then here we're also identifying greatest common factor of the coefficients, greatest common factor of the variables with the highest power. So that's what I have for you. And so Professor McStud is out.